Hi, good morning everyone. Paul Angus from ShapeBlue. Could you go through the introductions? You've kind of seen all these slides before about ShapeBlue. Yes, I'm getting old and I've been here a long time. We have some customers. So, I'm here to talk about the CloudStack container service. We've had it for a little while, but as ever we're always trying to upgrade things and move things along. And Kubernetes has moved on, and so has the versions of CloudStack, so we'll continue to move along with them. So I'll give a bit of introduction, look at the components that we're using, and some we've tweaked. A demonstration which I recorded because otherwise it takes too long, and so I even sped it up because I was getting bored and realised just how slowly I type when I'm sitting watching it go. So I sped that up a little bit, a little bit of our roadmap, and then some kind of summary. Now, I have the notes here to say what happened with each of these. I don't think you want to hear all about them. But basically, we started off with containers a long time ago, 1979, in Unix version 7. They had this root system call, which was introduced, changing the root directory of a process and its children to a new location in the file system, and this advanced with the beginning of the process of isolation. He says, reading that brilliantly. Then it kind of went quiet for a long time, until 2000, and then FreeBSD started inventing the thing they called jails. Linux came along with their own vServer, which was their own variation on jails. Still only a few years later, Solaris containers came along. What have we got next? That's the first beta, OpenVM. Process containers started appearing, and then 2008, what I guess most people would recognize LXC, our Linux containers. Cloud Foundry were actually early on in on this action with what they called Warden. And so, that was based on a lot of what came before it, and then they started writing their own proprietary stuff after that. We even got great acronyms. Let me contain that for you in 2013. And then it kind of went a bit quiet, except we had Docker then appear in 2013. So we had sort of started early, bit of a kind of lumpy moving along until Docker 2013. And then people were getting quite excited about that, including various other companies, until we end up with Kubernetes 2017. And as it says, Kubernetes grows up. This is where people really started taking one technology particularly seriously, where everyone had been going in their own directions with their own versions and their own combinations of things. Now people are getting on board. So Docker have now said that they'll support Kubernetes, Azure and AWS, rather than having their own versions of Docker and pulling things together. Said, oh no, okay, we're going to have a Kubernetes service as well, because that's what everyone's using. Was it CSEUG, their cloud native compute the foundation, besides that's going to be one of their big pushes to get everyone using that. And of course, what really made Kubernetes Day, ShapeBlue had their container service version 1.0, which was obviously seen by many as the crowning glory for Kubernetes. So why did we kind of decide to jump on this particular bandwagon? Why did we think this was the right time? Well, we were seeing this massive growth, and I've kind of tweaked this to now it was possible massive growth, and it turned out to be really quite massive growth in cloud-native applications. Now people are still trying to drive that forward with serverless and other variations, but they're still coming back to containers, sitting underneath that. And the wherefores of that, for anyone who's been not so involved in all of this kind of stuff, is that you're basically allowing those developers, whereas IaaS meant developers didn't need to worry about the underlying infrastructure, the server, the actual physical OS and things that are running. They didn't worry about the networking. They didn't worry about, oh, I've got to switch it on and wire these things up. Now the application developers don't even have to worry about the server itself and the OS. They can contain what they want in their version of anything, and that can be run smoothly anyway, which gives a higher density of their applications, gives a faster startup time, which means it's then able to create more of them and quicker. It gives you more flexibility in how you might use them. There's kind of knock-on effects of all these things. But one of the downsides in containers is multi-tenancy is somewhat of an afterthought when you start doing these and have a load of containers all next to each other. They haven't really been designed around the idea of keeping them separate and not sharing any kind of space, particularly obviously memory space, which got very exciting for people when various bugs came out. And for most people, Google, Amazon included, IaaS is mainly selling virtual machines, and that's an awful lot easier thing to manage because they're nice and big and you can't see them. They don't keep appearing and disappearing at anything like the rate that a container might. And so it's a lot easier to build for a virtual machine that's been running for a week than it is to build for a container that's been running for 10 milliseconds. And so there's still space in to play with virtual machines. And in fact, it's kind of how Google and Amazon work a lot of their services, is you still have a cluster, and that cluster is of virtual machines. Then you do what you'd like to do on top of that. So what we try to do with the container service is fit into that model and make sure that people didn't have to completely change billing systems, they didn't have to change a lot of the way their customers worked because they still were spinning up virtual machines in clusters. And so there was no disruption to how they were used to operating, no disruption to billing systems necessarily, if you didn't want them to. Which kind of covers the second developments there. And then finally here, we took, obviously, Apache CloudStack, because that's what we do and that's what we think is a great way of orchestrating things. Kubernetes, because, as you saw, it was, by this point, really becoming the de facto container kind of orchestration model that most people wanted to work with. And then Core OS, because we wanted to, obviously, we needed to base our VMs on something, and Core OS was there as a ready-made. All the inventing of the wheel had already been done. There was no need for us to go and create new templates and take an Ubuntu VM and then start installing things. It would create an overhead for us to maintain and keep secure, but it also meant people who wanted to go in and tinker would then have this weird thing that we had invented, whereas there is a stock Core OS image which you can use, you can download from anywhere, you can read how it was put together, you know what you're getting, you already have all the documentation to work with. We were very conscious, because the CloudStack community had talked about containers quite a bit and tried to work out where CloudStack's place in the container world should be. And so we were very conscious not to try and be saying, this is how CloudStack must do containers. There's no other way, this is the way, and we've now done it, and now tough if you don't like it. So we were very careful in the way we constructed this to make sure that people would be able to consume it if they wanted to, not if they didn't, and also in the way that we constructed the clusters, that there would be other things people could do within some of the framework that we put underneath this. So we made this open source framework of being able to create clusters of virtual machines which were brought up together as a cluster, and understood the idea that there would be a master and some worker nodes. But that doesn't necessarily have to be using Kubernetes. Anything that has a master and worker nodes would be able to fit into this framework and use the same APIs and the same ideas. So running databases as a service, or whatever you wanted to do, where CloudStack will now understand the idea of a cluster of virtual machines. Time to go next to the issue thing. Don't I press that? That doesn't work.
disable the settings. You can't do that on your phone.
Yeah. Oh, I can see that it's come on the phone. Outlook is on. I hope no one says anything rude. Okay, so the components of CCS are this application clusters framework. As you say, this can be used for other things. It's for creating clusters for whatever it may be. And an API there to work with that. So on top of that, we then added the idea of deploying Kubernetes into this cluster. So they're not joined inextricably. We obviously, that's what we're doing this for, is to be able to deploy Kubernetes on it. So we put that in, and also give ourselves a door in to talk to the Kubernetes API in these clusters to return state information to be able to feed that back to people. We automated within the startup of Kubernetes a dashboard. So Kubernetes has its own sort of little UI, a dashboard. Many people would use a CLI, they'll kube control commands and write in the time-honored Linux way half a page of text in order to switch something on. You can do that if you want, or you can press the button and you get that Kubernetes dashboard. The certificate service was mentioned in the things we added in 4.11. So we developed it specifically at the time when we were doing this work, but we then put it into CloudStack as its own thing. So we needed a secure authority to create connections to the dashboard, because you've got to have a certificate to talk to a Kubernetes cluster. But also it does a load of other stuff, and I'll cover that in a second. And then a UI to simplify, as I say, the interaction people would have with these clusters. So I can just quickly show you. So we've got new APIs like create an application cluster. So you can see, it could be Kubernetes Cloud Foundry, Mesos, the idea being that once people would develop different service types, because they're going to have different worker to node configurations. So Kubernetes would be one or two workers with however many worker nodes you want. Two masters, how many worker nodes? Mesos, Cloud Foundry, they're all going to have different relationships from the masters and workers. Some don't even have a master, they're all workers, so people need to just understand that. And then various parts of how that goes together. So you can see it was all built around the idea of these clusters could do other things other than Kubernetes, so we kept the framework in there. And then that was a sort of more detailed explanation. The other ones were deleting them, starting them, stopping them, increasing workers, increasing master nodes, whatever they happen to be, listing them, the kind of things you expect to do in CloudStack, and lists and creating links. But it's all around, say, a generic cluster, a constant generic cluster. So the certificate service enables the CloudStack management servers to be a certificate authority. So they can be an authority for anything that's then within the CloudStack realm, and then authenticate anything within the CloudStack realm. It enables it then to create client and server certificates. We use that for secure communication for an individual and the Kubernetes master node, but it's also used now for communications between the host agents and the management server and secondary storage console proxy VM agents in the management server. They have to sign in with SSL in both directions now, so you can't theoretically create a theoretical another KVM host that wasn't supposed to be part of CloudStack and come in and say, hey, here I am, log me in. It will say, but where's your certificate? And all the management within that is there to be able to expire certificates, to require updating certificates, to send out new certificates, say, okay, you now need to be registered with a new certificate for whatever period. I know one company uses this and their certificates rotate every 3 days. So every 3 days, it's got to be a new certificate. So they're really, I think default is a year, but they're down to 3 days because they really, really want their communications to be secure. We talk about Kubernetes as why. So the plugin is going to orchestrate this deployment of Kubernetes. So create a load of virtual machines. We're going to tell them, you're a worker, here's your configuration, here's you're the master node, here's your configuration, and we do that through user data. We just pass the user data through to them, and those core OS templates are designed to read user data and configure themselves based on it. And kind of in the spirit of CloudStack, we make sure we're just the control plane. So if you switched off the CloudStack management server or even uninstalled the Kubernetes container plugin, the containers you've already got will just carry on. We're not sitting there, it's not coming through us any data. We're just a control plane that has done the work to create these clusters, to configure them, and tell you what the credentials you're going to need to connect to them are. Let's go with the simple bit. So as a user, normally you would talk to the CloudStack UI, or you would talk to the API, and then via a virtual router, you would get to your guest virtual machine. In this new model with CCS, container service, you have the choice of kube control, which you can go through the virtual router and talk to your Kubernetes master, because we have, as part of the deployment of the cluster, told the virtual router that it needs to port forward, I think it's 6443, to the Kubernetes master. And put that open so that you can use your kube control to connect to it. You'll see later there's a lot of security between any end user and that Kubernetes master, so you can't just kind of just go to someone's Kubernetes master. You've got to know, you've got to have a copy of the certificate, you've got to know the admin password, and you've got to have a token as well. User then has, we've got a little slice here of CloudStack UI that we've added on for the container service, and that then also goes in dashboard. So the dashboard is itself a Kubernetes container. So what we've done as part of the startup is make the dashboard start itself up, and it will be running in one or more, depending on how many nodes you've got of these, which will just forward you through to. And then finally, as a user, you can talk to the CloudStack API, and this arrow here is showing that that's then talking to the cluster as a whole. So the API there is to talk to the cluster as a whole, which might include adding another worker node or taking a worker node out and doing other things in that API. Installation. It's surprisingly easy to install it. Though Kubernetes is complicated in itself, we've taken an awful lot of that complication out and taken it away. So for the operator of the cloud, it's creating a service account so that this service can talk to CloudStack and say, I want more clusters, I want this, I want that. Connecting your OS, wherever you're putting it, to repo where we keep the Kubernetes service, and a yum install to install it. Once you've got it installed, you can see, just tell it the type of hypervisor you're using. You can run it multiple times with different hypervisors. Basically tell it how it can talk to your management server and where it can talk to the management server. It will go and get the CoreOS template for you, install it, and you're good to go. You're kind of done there. That whole process probably doesn't take 10 minutes. It probably takes longer to get in and create a service account for CCS than it does to actually do all the rest. And then for that lid for demonstration, yes. So in this demonstration of varying speeds, I will create a cluster, see some of the metrics, you see the virtual machines coming up, and then I'll go into the dashboard and actually deploy a couple of applications to show you kind of how that workflow works through the UI. Now, I think I have to come over here to press play.
Too much of a coward to do it live.
Yeah, I'm kind of thinking that can only go badly. Okay, so I'm signing in as a normal user. The user is called CCS Demo. It's a bit hard to read it on there. And I'm clicking around to see nothing exciting going on yet. I have a container service tab down here. And here I've created an SSH key. You don't have to, but I'll show you when that comes up. To get into a CoreOS VM, you can only do it via SSH keys. So if you've created one, you can put that in here. You may not have any wish to get into the CoreOS VM itself, but if you do, use that. And what I've said in there is that I'm going to use what size of instance I want, how many worker nodes that I want, what I want to call it, and let it go off and create this cluster for me. And underneath now, we're doing most of the things that CloudStack would normally do. I show here, we're waiting for a virtual root to come up because it's going to create me a network to put this cluster on. So I've got a virtual router to spin up, so I've got to wait for that to happen. And I go to instances, and I can see I've got first instance coming up, which is the master node being the first one to be deployed. And hopefully, yes, I think we'll see it coming up, so CoreOS. Should have got better at, oh, refresh, right, we've got the second one, so our CoreOS master is up. I think I now go and grab the national that, and there we go, what is CoreOS default, that's starting to build. Still got one at the moment, so the other one must be starting up. I'll just let that one roll through. So at this point, there's not a lot we can do to speed this up. This is just CoreOS starting. It's doing its thing. Somewhere in there you do see a bit where it says reading things from container service. Somewhere. So about now we should have, yes, all of the other nodes up. So they've just got to boot themselves through the same process. Now we're still waiting for that to say started. So it's still starting. Oh, we just went to running, I don't know if you saw it flick over there. So we grab the password and there and the password. So that's unique for each cluster. Then there's a token. Currently the token is unique for each cloud, but I think we're going to remove that because although we've got a password which is also unique, we're probably using a unique token as well to add to that. I think you think of this like I'm not being patient. So it's like clicking things and we came up.
So even your recorded demos go wrong.
And it's going, well, I mean, Adam knows if you just wait a bit, it works, doesn't it? And then, see, I used the pop-out button because as you can see, quite a lot's happening here. We've still got another pod that's just finishing getting itself going. There's so much information here in that little box, it doesn't really fit where it used to, so that's one of the things I have to do really to pop out to a full-size browser. So, back to there. Let's go from the beginning, everything's up. And so now I get to create an application. So I've added loads of stuff here where you can do things yourself. The application, I'm just going to get from Docker Hub. So you do have the option to have a private repository, which you can use and create your own repository. Here I didn't, so I'm just using basically when I put anything here, it's just going to go to Docker Hub. So I'll get whatever it wants. I'm creating my application. Imagine it's called Pools Nginx. 2 pods, so I'm going to have 2 pods, which will be one on each virtual machine. Externally exposed port 80. Deploy that. So that says 0.2 so far. So I'll create another one while I'm at it. Ghost. So this will be Ghost. Pointing CloudStack forever. Again, we'll have 2 pods, and it has some weird port that it likes to expose things on. What is it? 2368. You can see we've already got our Nginx one going and our Ghost one's nearly. It's just starting. A bit of a refresh. Yeah, we've got them all. So they've all spun up. You can see I actually still within the container service kind of tab. We added the firewall piece on there, so you don't have to go all the way back out to your network to start setting up firewall rules and port forwarding. But here I'm adding port 80 and 81 in, so I can connect inwards. And then adding some load balancing rules. So I've got my Ghost application, and port 80 I'm now in, and I need to go and get the. You'll see there's a funny port it will be on over there. Oh, hang on. There's the node port that I'm going to put in, but I also need to tell it it's using node ports. There we go, just there. Because otherwise it'd be kind of trying to talk internally, and I want it to talk out, straight out. So you have to go and change those. And suddenly these come up with ticks as being externally exposed, and it's happening. I like the ticks. So I'm copying my port that is going to be exposed on the node port, and I'm writing them down over here, which is one of the reasons I sped this up, because it turns out I type down slows up. So I'm copying and pasting them into there, slowly, bear in mind it's sped up. Setting it to, what's that? Source, algorithm, connecting, and I'm going to load balance it on both virtual machines, because that means there'll be a node on each virtual on each virtual machine, and so whichever virtual machine's up and got a node on, that's where my load balancer will happen. It's cool. So I could have had 10 of these things and just load balanced across the lot, and whatever was up would take the requests. So I've added Ghost and I've added Nginx on port 80 and 81. I think I've done everything I need to, but I'm obviously having a think just to make sure. Everything's green there. There's my overview. Everything's green here. I've got 2 pods of 2 up in both cases there. And so I need the external IP address of my pod, because I want to connect in from outside and create a service for the world to use. And I've used the first one on port 80 and I've got Ghost, and the second one on port 81 and I've got Nginx in. So the world is a better place for another blogging platform and another copy of Nginx. And that should be the end. Start thinking about it. Yeah. Okay. So a demo, which mostly worked, of the kind of thing now, as I say, people who are doing hardcore things with Kubernetes, this is all a bit noddy for them, and really, it's like the point they're going to have multiple applications that are starting and stopping, and they're all going to be interlinked. But the premise is the same, that they would go and do these things. The cluster has been created for them. None of that messing around. The YAML goes behind this cluster is meaningless. But we've abstracted all the things. You can just ask the important questions of how big do you need this thing, how many of them. We'll go do all the putting together for you, and then you can do what you like underneath. Change the networking model. I think it's Flannel by default that you get with Kubernetes. You can change that to Flask or whatever else you want. But it's got Kubernetes on CoreOS, so it is a full-blooded, full-blown everything you could want to do. Oh, I just found the start stop. Right, back to here. So, the summary. We created our cluster. We saw the dashboard that got deployed. Created a couple of applications. We gave our firewall load balancing rules to expose them, and we accessed them to prove that it wasn't a trick. Though we did that creating the firewall rules, there is within Kubernetes, I think, was it Sebastian and the skip box, put into Kubernetes, it understands CloudStack. So you can ask Kubernetes understands CloudStack, it's written into the code. So you can ask Kubernetes directly, you can tell it it's in a CloudStack cloud, and it will go and create those ports for you. So it is capable of doing it the other way around as well. So, where are we now? Well, the plugin, in its previous iteration, we know it is in public use and in private use. We know ISPs are using it for their customers, and one of them also uses it internally. So their dev team uses that to create their clusters, get on with their development, see how it looks, and work out what they want to do going forward. But they also have that in their UI that their customers use. I know a few in the US, so it's quite surprising when you went to a conference in, I think, Miami, something came out just and started talking to us. So who are you? But it turns out he'd been using the container service, loved it, and things he wanted to tweak and what have you, which we take on board, and it was all really exciting. So at the moment, this plugin is now being polished for 4.11, making sure nothing's changed in there. And obviously, Kubernetes like to keep updating their versions, so that was the very latest version as of about a week and a half ago. I refilmed that, so it's probably 5 versions old by now. But a week and a half ago, it was the current version of Kubernetes core OS. All the source code for it is all available, open source on GitHub. As I say, we try to keep the separation between the containers and the clusters separate, so the cluster piece is still ongoing, getting it into CloudStack. Because where people want you to stop working, is we can put the basic one in and then maybe iterate. People would like to see it all finished before delivery. So that's still ongoing work. But also our roadmap, which I'm going to put next, the roadmap as to where we go, because we do have people actually using it, is very much informed by what people want to do, who have got it using it in Angular, and saying we can really do X or Y on top. And that would be things like supporting shared networks, only really applicable in private use cases, because you don't really want to in a public cloud start putting all of these containers, clusters on the shared network. Auto resizing and auto healing of clusters is so that Kubernetes reports that one of its nodes pods isn't running or working. CloudStack will then maybe just destroy the VM that node's on, create a new one, and add it back in. Being able to upgrade the Kubernetes version via a nice little button instead of doing it yourself. Resizing the nodes, HA master nodes, all the kind of things people might want in their container service. And an interesting one, we work on the bare metal deployments. There were people who still very much believe that containers shouldn't be in VMs, they should be just on bare metal. You should just give people as much physical oomph as you can and then let them run containers in that. CloudStack can work with bare metal deployments, so we'd like to bring those together and then you can say, okay, well now we'll just deploy CoreOS directly onto some tin and then you run your containers on that. And there we go. How we do it? So did you want to do a question later? Or
you can take a few if anybody's got anything.
Take a few questions now. Yes.
So is it supported on both KVM, Zen, VRAM?
Yes.
It's agnostic.
Yeah, it's agnostic, because we're just asking CloudStack to create virtual machines and pass them the user data from the Kubernetes point of view.
And it's isolated networks only?
Yes, at the moment, yeah. And it will, the best way is to let it create its own isolated network. Just in case, for instance, you haven't allowed user data. So if you have a network that doesn't have user data, we can't pass anything in. You're just in CoreOS VM.
How did you pass user data now? Config drive or?
That's still through the original directly by the virtual router.
Right. And the host VMs are just on a flat network, 10 or something, right?
The host VMs are in an isolated network between themselves, so...
Okay, so just normal, simple, not very basic kind of network.
Yeah, just a very simple isolated network they sit behind.
Why did you modify the configuration? It was going so quickly. You modify the configuration in Kubernetes from nodes cluster to something else.
In there?
Yeah, in the Kubernetes.
I don't think so. All we do is...
You said traffic, I don't want traffic to go like this, I want it to go like that, but I couldn't really follow what was going on.
I don't have to go and look at exactly.
To node something.
from?
Oh, when I physically changed it.
Yeah, you edited the configuration of the
Oh.
Kubernetes cluster.
Yeah, that was of the. That's getting into actual Kubernetes, but it was so that that port was able to be exposed straight outwards. Normally, they would be exposed only internally to other bits of Kubernetes, other things within your cluster, and I needed it to be exposed outwards to the wide world. Because if you create any application with, you're going to have ports open so they can communicate. You don't want every one of those ports exposed externally.
Yeah.
So what I was saying is this was a port that I need exposed externally.
Okay.
So, I mean, the virtual router in your deployment was as a load balancer, and changing the configuration is quite involved. If you scale up your cluster, you have to update it.
Yeah, I mean, for
It
this,
doesn't happen automatically.
normally you would be doing that as part of the build in the first place. And you would have almost, you'd be building a distributed application underneath. But I just want to demonstrate what we could do there and have it AJ in a very simple way. You wouldn't want CloudStack to be having to be the load balancer in there. Kubernetes has a dedicated type of load balancer internally. But for the purposes of the demonstration, that's what didn't want to then spend half an hour creating Kubernetes load balancers for people to see. This was just to show how you can make that work in a very, very simple way.
So in production, you wouldn't use the VR load balancer, you'd use the Kubernetes load balancing thing?
I don't know enough about Kubernetes to say what I would and wouldn't do in production with Kubernetes. I would probably be looking to use a combination of two in some way.
Yeah, Nginx will be load balancing as well.
Yeah, I mean, in some ways I would maybe have, I would have the distributed load balancers that understood all of the nodes that I had underneath, and then one, it's pairs you come in from external, go into those load balancers to say, right, deal with what you need to underneath, but this is my ingress from the outside world. Because you've got to point in the outside world at something.
If I wanted to run, is it possible to run this in a security group advanced zone?
Not at the moment, no.
Because if Kubernetes supplies the load balancer, and we already have the security groups, we're kind of almost there, maybe?
Yeah. Say it's...
And it would be simpler in terms of letting the Kubernetes do
But also remember, Kubernetes is CloudStack aware, so the Kubernetes, your application Kubernetes could send a command to add another element into load balancing rule from Kubernetes, so you don't have to do it twice. But you've got to tell something to port forward to something else as well, or load balance to something else as well.
Did you guys actually test this feature?
No.
Kubernetes CloudStack.
No, I mean, we're getting close to the edge of my Kubernetes knowledge just doing that.
Okay.
I can do a bit to treat clusters and query them and break them, but fixing them afterwards is above my pay grade.
Yeah.
Anybody else? Please no. Thanks.
Thank you, Paul.
Thank you very much.
Okay, so next up we